Hello, hello. I hope I am audible. Let me quickly know in the comments. I hope I am audible. Okay, so let's start now. Contest live. So my name is Sagar, and we are back here with our another live stream contest. So this is GFG Weekly Coding Contest 86, and that was formerly interview series. So you can join the contest. That is link is in the description. You can click on that link and you can join this contest. So let's start now. So I just cannot guarantee that we are gonna solve all the three problems, but I can definitely say that the one problem I will be solving, you will definitely understand that completely. So this is split the string. We are given a string s of length n, and we have to split them. Okay, split that into two strings such that the number of common characters between the two strings are maximized and return the maximum number of common characters. So this will be something like this, and we have to divide it ABC CBA. Okay, we can just take characters from in between. I think AB PDB. Okay, yeah. I think we can take characters from in between the string. Let me just check first. So I will just return here some value, and let me just check for the test case. So for this test case, the answer should be 3 because in our one string we can just take A, B, C, and in our second we can just do the same. So if the answer is 3, then this is a very simple question. Okay, our output is 0 and their output is 1. Okay, we have to take care substring, right? So first of all, we have to check this string that this is 1, this is A, and after that we have to check for our next string that what is the maximum number of characters we can have. So let me check for time complexity. So time complexity is 10 to the power 5. We have to optimize it from n square. I hope I am audible. Let me quickly know in the comments if anyone is here. we have to we have to divide it into two strings and we have to maximize the number of common characters. So we have to make a substring and we cannot choose any character from in between the string. So that is the main constraint. Okay, and let us wait for this to load completely. So what will be our approach? So let me just think first. We just cannot go for our n square time complexity because constraints are high. So first of all, what we can do is we can just count all the characters, but that is I think not helpful for us because we just cannot count the frequency of all the characters because we have to add here substring. We have to take the substring here. If you are taking ABC, then we have to take here CBA. Or what we can do is we can first count the whole substring, how many values of ABC, how many values of a particular character are present, like in our frequency array. So we can just take this thing, frequency array of length 26. I hope there are only lowercase characters. Yes, there are only lowercase characters. So what we can do is first we will count the whole, what we can say, frequency of all the characters from A to Z, right? So first we will count all the correct frequency of all the characters, and after that, first of all, we will just select this A, and we will reduce the frequency of A from this frequency array, right? Because in our first string, we will just consider A, and in our next substring, we will consider this. So first we will check after removing the frequency of A. So what will be the frequency of this A? Okay, we have to make here these two frequency arrays, right? And this will be our frequency 1 and this will be frequency 2. Okay, hi Avijit, hi Shivam, hi Ashutosh. So here we will just create our two arrays, and I hope now you understand the approach. If not, I will just tell you. Okay, this board is taking a lot of time. So first we will just count the frequency in this whole array, or we can just say this is our first string. So I can just say this is our A string and this is our B string. So first of all, we'll select all the frequency of all the characters in our one string, in our one array. And after that, first of all, we will just reduce we will just take this character a in our first string. So what we will do, first of all, we will reduce the frequency of this a from our second array, and we will increase the frequency of this a in our first array. So that's how we will take one character at a time in our one string. Okay, so that's how our time complexity will be also optimized, and we will just check what is the frequency of a, and here we will also check what is the frequency of a, and here we will check. Okay, let me just write here code, then you can understand easily. So first of all, we will suppose that all the characters are present in our second string. Okay, so that's why we will just add all the frequency of all the characters in our b array. I hope you understand this thing. So let me know if you are getting my point. So first of all, we'll traverse in all the characters. So what we are going to do is b of this character s dot char at I minus a, and we will just increase this. So this word is taking a lot of time. Let me reload this. So first of all, we'll just add all the frequency of characters in this second string. Okay. So frequency of A will be 2, frequency of B will be 2, and C will be also 2. Okay. And after that, what we will do, so first of all, we are filling our second string. And after that, let me write here fill. Okay, so after that, what we are going to do, we will traverse all the character one by one. That means first A. So we will take this A in our first string. So that means we will reduce the frequency from our second string and add the frequency to our first string. So let me just check here. Fill the first string, and we will also traverse in the complete string. I should be less than s dot length. So first of all, this A character. Let me know if you are understanding this approach. And I think the internet is also good. So first of all, we will just get this character A. So first of all, we will reduce the frequency of A from our B array, because now we have to consider it in our A array. So what we can do is A of s dot char at I minus A. So I hope you already know this thing, this basic thing. We have the sky value of all the characters, and we are mapping them to 0. Okay. So first of all, we are adding the frequency here, and we will just do the same thing, and we will reduce the frequency. So minus minus. All right. So we just added this A to our first string and removed this from our second string. So our second string have this B, C, C, B, A, and our first string have this A. And now we have to traverse 26 characters, and that will take not a lot of time. So what we will do, we will just check the frequency. How many same characters are there? So 0 to 26. They should be less than 26. And here we will just count number of same characters. Same equal to 0, and we will also create a variable for our answer, max same characters. And let me just check if, okay, how can we check? So first of all, if only one character is equal, then okay, I can just simply write here same plus equal to math dot minimum of a of j and b of j. So what is going on here? Let me just explain. So what are we doing? First of all the characters are 0, and only A have one frequency in our A array. Okay, in our first string. So we will just get the frequency of A, that is 1, and also in our B array the frequency of A is 1. So we will just add 1 to this same. So that means one character is same in both the strings. Okay, and that is here A. So I hope you are understanding this approach. And we only got the first character as same, and after that we will traverse in other characters. So B, the number of same characters in B is math dot minimum of how many B's are present in A and how many B's are present in B. So in our B string, so the total number of B character are present in, we will just take the minimum. And why we are taking the minimum? Because here in A number of B's are present is 0, and in our second string the number of B's are present is 2. So we have to always take the minimum, because we have to find the common characters. And if there is no common character present in our A string, then we have to obviously take here 0. So this will do our work, and at last we have to do max same equal to max same and this same. Okay. So I hope this thing will work now. max same. And let me just check. So this will be our complete approach, and the time complexity is here 26 into this n. Okay, and answer is correct. Let me just check for this test case. Okay, our answer is correct. Let me just submit. So our time constraint is also clear. Okay, we got a wrong answer, and this will deduct our marks. So let me just take this example. So in this example, what is going on here? So first of all, we are storing the all the frequency of characters in our B string. After that, answer should be 8. Answer, okay, what was the expected answer? I forgot that thing. I think 10 and 8. So that was something. I think my answer was 8. My answer was 10 and expected answer was 8, right? So first of all, this B. So my answer was 10 and expected should be 8. So 1, 2, 3, 4, 5, 6, 7, 8. And number of B's present are 1, 2, 3. Number of A is 1 and PIU. So number of A's present are 1 here and number of B's are present. So there is no number of B's present out there. So we have to increase the length. So think, okay, we will just do it here. So first of all, we have to store the frequency of all the characters. Okay. So first of all, we will count how many number of A's are here. So this is our first A, and this is our second A. This is our third A. So I will just store the frequency third A. There are total of 3 A's, and I think I'm not missing anything here. Okay, so check. Let's check. So number of B's present are 1, 2, 3, and I think there is no B present. Okay, I can just do this. So number of B's present are 3. Let me just write here 3. And a number of C's present. Okay, there is no C. And number of D, no D. P, 2 F's. So it is C, D, E, and let me just write here C, E, and number of F's are 2. And G, and after that frequency of J. Okay, there is no J present. K is 1, L is 2. K is 1, L is. You can also create a map here if you don't understand this approach. M, 4 M's are present, and N, so 2 N's are present. So let me know if you understand what is the problem. Okay, expected was 8. Okay, okay. Okay, we'll just see. So N number of N's are 2, and after that O, so 2 O's are present. O's are 2, and OP. So total number of 2 P's are present. P, after that we have Q. 2 Q's are present. Okay, this is taking a lot of time. R, S, T, W, X, Y, Z. R1, 4S, Q3, there is one W here, and one X, T Y, one X, T Y, and number of Z. Okay, there is no Z here. So how can we? Okay, we have to now check this code. So first of all, we are checking for B. So we have to remove B from here. So this is A, this is B. Okay, this is looking mess now. Okay, we'll just do it. So first of all, we have to reduce the number of B here. So the B will be here 2 and number of B is here 1. So total characters are 1 now, and maximum total characters are 1, and after that we will reduce frequency of P. So after that P will be 1 here. Okay, let me just write here a map. So first of all, P will be 1 here, and here it will be 2, and the maximum characters I will write here. So 1 is the maximum number of characters, है ना? And after that frequency of P will be 1 because P was 2 times, है ना? Here are 2 P, and here P will be equal to 1. So after that I have again B. So I reduce the frequency of B from here, and it will be 1 here, it will be 2 here. So the maximum number of total characters are 2, and it should be 8, right? So after that I have this I. So if I'm taking one I out of here, A B C D E F G H I. Okay, how many I's are present? Let me check here. Only one. So number of I's are this. This is I. So this will be removed from this, and it will be 0 here, and I will be 1 here. And let me just take this, and after that we are taking again B. So it will be here 0, and after that next A. So we are taking one A out of here. So A will be 2 here, and the number of A will be 1 here. So total number of common characters are now. So now we can see A is common here one time, and this is C. No, this is I here. So I is not common here one time, and P is common here one time. So A and P. So maximum will be still 2. And after that we have H. So we will just take one H common. H will be 1 here, and H will be also 1 here, and now the maximum number of common characters are 3. I hope internet connection is okay. Let me just debug this thing first, and so after I hope. Okay, now the stream is paused. I hope now you are getting this. I hope now you can see this thing. Let me know. I hope I'm not audible now. Let me know if you can see this screen. Okay, I hope we are back online. So we'll just start again. So we were debugging this solution, and I hope we were just doing something wrong here. Let me just debug this question, this example. So there were a number of B's. Let me just search it again. Number of A's present are 1 and 2. So common number of A's are 1. And after that number of B's present are 3 here. So there is no common B, and no C, F. So there is no number of common F. And I think we can divide this here, and the number of F and G will be common. So if this is our string, then how many number of common characters are here? Let me just check now. Number of A common are 1 here, and after that number of common b's, no common b, no c, e, and f. So number of f present are 1, and after that g. So there is one number of g common. So this is your 3 answer now, and let me just write it here. Okay, so there is total number of 3 present. That is your a, b, a, f, and g. Okay, and after that let us check h. So there is no h present, and then I, no I, j, k, l, m. The two m's are present, so it will be here 5. Okay, and the answer should be 8. Answer is 8, and our answer was giving us 10. So m, n, so there is no n present. O, p, q, so there is one number of q present, so answer will be 6 now. R, so two number of s, and the answer is now 8. P, q, so one number of extra u here, so answer is 9 now. P, no v here. Q, x, y, and I think y, one more y here, and the answer is now 10, and then z. So I think our answer is correct, and we are getting, okay. So I think our answer is correct. We are getting 10 common strings in 10 common characters in this one string, and this is our second string. So we are dividing it from this, and just confirm this thing. We are getting 10 common characters, but the answer that this their compiler is giving is 8. Let me just check again, and we'll just move to our next question. I think this question is correct for from our end. It is a lot of time that GFG have this problem of giving wrong output. See, our answer is 10, and their expected output is 8. But we can see here we are getting 10 common characters, okay? And we are not violating any rule, I hope. So just confirm this thing, all right? And we are getting our 10 answer. So we will just move to next question, because we just solved this question with our O of n time, and they are getting our wrong answer. So now we'll just solve this. Okay, let me just solve first second. So we are given an array of size n. We have to make the array special in minimum number of operations. So what is a special array? Array is called as special if all the elements are equal. If all elements are equal, okay, we have to make them all equal. And an operation is defined as take any subarray of size less than 3 and replace that subarray with its maximum element. Okay, we have to take only subarray of size less than equal to 3 and replace that subarray, that whole subarray, with its maximum element. So suppose for example, if we are taking this subarray, then we can replace this whole subarray with 7, and after that we can take this subarray and replace this whole with 7. Okay, that is the, I think that is the only explanation here. We can take 1 to 7 and replace this whole subarray with 7, and replace with 7, and after that in our second operation we can take our second subarray, that is here 2 to 7, and replace it with 7, and the remaining values will be 7 7 only. And in this example, so in this example we can take 1 to 7 and then 2 7. So there are two number of operations. So what is our observation here? So first of all, see that thing we have to take here. If we have to make our all the elements equal, then we have to obviously make our make elements in our with the maximum value, right? So we have to take this maximum value, and then that means we have to take all the subarrays that don't have this maximum value, and that means we have to make our subarray with all the maximum values, right? I hope you are getting my point. I hope you are getting this thing that first of all we have to take that subarray which have only one maximum value. So first of all we have to find the maximum value from our subarray, because we can never remove that, right? So first of all we have to find that maximum value from our subarray, because if there is one 8 in this subarray. So suppose for this example, let me just show you. Suppose there is one 8 present here in this subarray, 127, then 2278. Then that means we just can never replace this 8, because if we are selecting any subarray, then that means we have to replace it with the maximum value. So if we take this subarray, then we are replacing it with 7. If we are taking this subarray, we are replacing it with 7. If we are taking this subarray, then we have to replace it with only 8. So that means at last, if there is any element present in our array, that will be obviously the maximum element of our array. So that means we have to find the maximum element. Int the minimum element present is 1, so we can take it as 0, and we will just get the maximum element of our maximum element and every I. So that's how we can get the maximum element. And after that, what can we do? So first of all, we have to take only subarrays with size less than equal to 3. So I think we can just go greedily. We have to take any subarray. I hope voice is clear. Let me know if my voice is clear. The first solution didn't work actually, and the reason is we are getting a wrong answer. We are getting a right answer, and their compiler is giving a wrong answer. That's the case. We are returning a right answer, and they were not accepting it. So let me just see, we can go here greedily. So first of all, what we can do, if we have a maximum element, then we can just start by taking any subarray of size 3 with this maximum element. And what we can do, we can create here array list, because we just cannot manipulate our array are static, right? So we can take any subarray, and after that we can replace it with the maximum value. So it will be here 8, and after that again take this, and again replace this with 8, and again take this whole subarray, and again replace it with 8. So I think this will be our brute force approach also, and also greedy approach. So at last we have to do 3 operation, right? So let me just think that here. So first of all, 1 to 7, and then 2 to 7. So first of all, we will get the maximum element, that is 7, and after that we can just find where is 7, and we can just select any subarray with the size. So first of all, we will just start from taking value from our starting point, right? So first of all, we will get 7, and we will take all the value up to this point. So we will get 3 values and replace it with 7. And I think we can use here a stack, maybe. I don't know, we can use here a stack. So first what we will do, we will just put here this 1, this 2, and this 7. And then what we will do, first of all, if we have a 7, then we will just remove the, if we got a 7, then we will just remove corresponding 2 values, maximally 2 values, because we will not add 7 here. So whenever we are at 7, so first of all we will add this 1, this 2 values, removing one subarray and adding the maximum element from them. Or yeah, that is the case. I think that can be our greedy approach. Or we will just see another example. So after this 7, we have this 2, this 2. Okay, we just cannot add here 7, right? So when we don't have to add 7 in our stack, so after 7 we can just say that this is our 7 in our hand, and after that we can just add 2 and 2, and whenever we have 7, so we'll just remove all these 2 values, and this is our second step, right? So so what we are doing here is, first of all we are taking this subarray and replacing it with the maximum value, and after that we have 7 2 to 7, so we are taking this subarray and replacing it with the maximum value. So at last our number of operations are, this is our first operation, this is our second operation, and that is our brute force approach. So let me just think of some another example. Suppose we have 1 1 1 1, and then 7. Suppose this is our example, then how many number of operation do we have to do? First of all, we will take this subarray and replace it with 7. So this is our first operation, and then we will take this subarray and replace it with 7. So this is our second operation. This is our second operation, and after that this. So this is our third operation. Total number of operation are 3, and all the elements will be equal. All right. So I think let me just confirm this thing. 5 and 1, 2, 3, 4, and 5. So first of all this, okay, total number of elements were 6 here, 1 here. So first of all we will take these 3 values, and after that these, and then this. So answer should be 3. Then our brute force approach will work. So bro, I have to also keep explaining this thing to you. That's why I'm talking more and coding less. Okay, we have to first return some value here. So I will just return here 3, because that is our answer for this test case. I'm not here to just provide you all solution of this contest. I'm just here to explain you the problems live on this contest. That's how, so that you can also approach to any problem live. So our answer is 3, and we can just go here brute force. So what we can do here is either we can also use here stack only. So let me just think. 1, 2, 3, 4, 5. So if we are using a stack, okay, suppose we have this case, not this. We have 7, 1, 1, 1, 1, 1. So if this is the case, then we just cannot create a stack here. I think, yeah, we cannot create a stack. We can just go brute force, but we are back here. Let me just start. While phi is not equal to max element. So I hope this thing is clear. Let me know if I am visible and audible. So first of all, we are creating an index, and the index will be from this point. And if we have also other values here, then first of all we will just add these value in our stack. So 1, 1, 1, and after that when we have stack this 7 in our hand, then what we will do, we will just remove these two values, and that will be our first operation. So I have to now write this thing in our code, and after that this will be our first operation, because we will be just taking this subarray, and we will replace this whole subarray with 7. And after that we have to take now this subarray, and one value from here and one value from here. Okay. So how can we write this thing? So first of all, we have to write here while I is less than n. So I hope that will be our base case, that will be our condition to break. So now we have to check, we have to remove two values from our stack, and if there is no two values present, then we have to take the next value. Okay. And if the next value is also 7, so suppose if this value is also 7, then we have to still take this subarray, this whole subarray with this 7. Okay. And we have to also increase the index side by side. So now the condition will be, if, I think we have to remove only one value. First of all, let me create here answer, that will be total number of operations. So first of all, remove one value from our stack. If not, stack dot is empty, and we also have to take a pointer that will tell how many values we are taking. We have to take two values, right? So I will just take here count. So how many values we are removing? If stack is not empty, then we have to remove a value from stack, and count will increase. Again we will do the same thing, because we are never adding this value in our stack. Okay, so while our this ith value is not equal to our maximum value, we will just add all the values that are not our maximum in our stack, which are not maximum and before that maximum value. Okay, so we'll just add all these value in our stack. So after that, I will just check if count is less than 2. So what we have to do now, we have to take next further values. Okay, so if in this case our count is here 1, because there is only one value present in our stack. So now we have to take next values. And how can we take next values? So we will just take this ith value, I think. Okay, we have to also increment I here. So let me just try this thing what we are doing here. So first of all, we will add this one in our stack, and after that we are here. So we'll just add this, and index is also at 7. So after this we are in this block, and count is 0, so we'll remove one element from our stack, and after that our count is 1 now. So now we have to take this value. So this value will be equal to this value will be at our I plus 1 index. So first of all, we have to increment our I, and after that we will take that value in. We will just remove that value. So if we have to remove this value, then how can we remove it? So we cannot just consider it, we can just ignore this value, and we will again increment our I. So we can just increment our I again, and that is where we are incrementing 2 times, and that is because first the value of I is here, and then we have to be this value, because we have to also consider this in our what can we say, in our sub array. So I hope now you are getting this thing. So first of all, we got this value, and that can be also the case when our count is equal to 1. So we have to write multiple cases here. If count is equal to 0, then we have to add two values. So if count is equal to 0, then we have to write another case. So if count is equal to 0, then we have to check for, then this will be something the case. So 711. So here we are at here, and the count is equal to 0, and there is no element present in our stack. So we will not enter in these conditions, and count will be 0. So then we have to take values. So what we will do, so this is I plus 1, this is I plus 2, this is I plus 3. So we will be at I plus 3, I equal to I plus 3. Okay, and count will be equal to 2 now. And our second condition is else if our count is equal to 1, then we have to take only next value. So I will be equal to I plus 2, and that is because, so we have here first value, and we have to take this subarray, and we have to be at this value. So I hope now you understand this thing. First we removed one value from our stack, and after that this is our ith value. So I will be here, and we have to be at, we have to also select this value. So we will be at I plus 2 index. So we will be at this index. Okay, and there can be also, okay, that is not the case every time. Okay, so what we will do is, first we will increment I here, and then what we will do, I plus 2 here, I plus 1 here, else. So let me just frame this thing again. So I plus, why am I doing here I plus plus, and that is because first we will just break from this loop when we are at our maximum element, and we will just that can be this case when we are somewhere in the middle, and that can be the case when we are in the starting, and that can be also the case when we are at ending. Okay, so there are three possibilities, right? And we will just see all the possibility here. So we are incrementing I plus plus, and that is because we don't want this I to be at our maximum value. So we will just break when our I is at maximum value. Okay, and we are incrementing I because we don't want it to be our in our on our maximum element. Okay, so this should be not our case. I should be less than n, or our stack should be also not empty. We will just run in this block if our I is less than n, or our stack have some value. if not stack dot is empty. So what we will do here is, so first of all, we will just increment our I in every case. So we will just increment our I here, and we will be at this index. We will be at this index, and here in this case, here in our second case, we will be at this index, and here in our third case, we will be at out of bound, and we will be at n. Okay. So what we will do is we will enter in this block because either our I is less than n. So in both the cases, I is less than n, and in this case, I is not less than n. So we will enter in this block because our stack have some values, and our stack have multiple values that are these two, these one. Okay. So what we will do here is, so we will enter in this block and we will take count, and the count is because we have to take the size less than equal to 3. Okay. So first what we will do in this case, so in this case count will be initially 0. If stack is not empty, then we will remove one element. If we will remove two times, okay, because we have to take three elements. So this element is in stack, so we will remove it. So here in the case count is 1, here in the case count is 0, and in this case count will be 2 because we will just remove these two elements. Okay. And after that, now we have to write conditions here. So I hope the audio is clear. Let me just know in the comments. So what we have to do here is, so first of all, count will be 0 in this case. So we are checking for this case. If count is equal to 0, then we have to take next two values. That means I is at here, and we have to be at this index. We have to take next two values. Okay. So we will take this whole sub array, and that means so I is equal to I plus 2. So I is equal to I plus 2 here, and count is equal to 2 now because we just take two extra element with our maximum value. Okay. And after that, in our one case, when count is equal to 1, so in this case, so count is equal to 1 because we just removed one element from our stack, and now we have to take this value, this ith value. So I will be equal to next value, I plus plus. You can just write here I plus plus. So I is at here, and we should be here. Okay, we should be at n, and also in this case stack is also empty and we are also at n, so we will just do one operation. And else, so else in this case when I is equal to 2, so we just removed two elements from our stack, and we are at this n, so our stack is also empty, and else in this case we don't have to do anything. So what we will do is, after this we will just remove one operation, and that's it. Return answer. So I think we are missing any base case, but we are missing some edge cases, and we will check. So we will check for this case and this case also. Let us just see if we are getting the right answer here. Okay, we are getting the wrong answer, and let me just check what is the problem. Getting the maximum value, and we are creating the stack from our 0th index, and while our ith value is not equal to maximum value, so we will just add all the values in our stack. So this value is not equal to our maximum value, and this will be in our stack, and this second value will be also in our stack. Okay. So our stack will be something like this, and I will be here, and this is equal to maximum value, so we will break out of the loop. So we will break out of this loop, and we will increment our I, this element, and our count will be 1. And again stack is not empty, we will again remove this element, and count will be our answer here. So our answer is 1 because we just take this subarray and remove these two smaller elements. Okay. And after that, now we are at this index. So what we are doing here, so after this value we are not incrementing our I, and our stack is also not empty. So our stack is empty, so we will not enter in this block, and this time our count is 0. So if our count is 0, then what we are doing, we are incrementing our I two times. So our I will be at not this index, I will be at this index. Okay. I is at this index, and after that count is equal to 2, so we will just increment our index, we will just increment our answer. But so we just remove these two values. So what we did in this step is, we just take this subarray because we just incremented our I from here to here, So that means we just taken these two values, and that is with this 7. So these two value with this 7, and that means we just remove these two values. So we just remove these two, and after that we are remaining 7 7. And I think now we also have to check that if there is only 7 present, then that means we should break. So how can we check this condition, that if both the values are maximum, then we should break? So I think there can be also another base case. There is also another base case with this example. If 7 is not present here but here, let me just wait. So if in some case there is this 2, this 7, and this 2, so what we are doing in our brute force, we are first taking these three elements, and we are replacing them with 7, and after that we'll just take these two and replace it with 7. So that means we are taking two steps here, right? But we can also do it in one step, and let me just show. So this was 7272, and we can just remove this and replace all the 2's with 7, and this is your one step process. So we can do it in one step, but with our brute force we are doing it with two steps. So that means this approach is not gonna work. So we have to think of something else and not stack. So how can we do this? I think we have to take the index of all the maximum values present in our stack, all the maximum values present in our array. I think we have to get the index of all the values. Let me just know if I am audible. My voice is clear. If you are able to see the screen. We are wasting a lot of time today, but we'll just see. So how can we solve this question? We have to definitely take the maximum value. We have to also store the index, I think. And by storing index, we can just take the values either from this side or from our starting side. So I will just remove this approach. We also have to store the index in our set. So we can just get the set here. I think we can also use here some different approach of let me just think. If we are taking this thing, if we have 1 2 7, then 272. Okay, internet is very weak. Okay, sorry for this interrupt. So if this is our example, then what we can do is we can get the index of this value and this value, and we can also create a boolean array with this value as true and this value as true. This is just a random thought. Okay, no, that is not gonna work. I think we have to remove the values from our index. We have to remove the values. So this and our affected value will be 0 1 2 and 3 4. So for our value 4, we have to definitely take this value 5 and this 3. So first of all we have to take this last value, because this will be the one who is affecting this last value, and for this we have to take the two initial values. So all these two, 0 and 1. So for this subarray we have to remove this 0 and 1s, and I think we have to create a sorted array. In split the string, don't take this value, rather than take if I is greater than 0 and this is greater than 0. Okay, so we have to take let me just complete that thing. We have to take character number of characters equal. Okay, So we have to do this, right? I think that is the thing you are saying. If a of I is greater than 0 and a of j is greater than 0. I think that is the thing you are saying. Let me now check with this example. So I think we have to consider the maximum characters equal, not the maximum count of characters. We were taking here frequency, but we have to take here maximum characters equal. Let me just check for this example first. Found error. Okay. A of I, we were taking a of I. This is a of j. And let me just check for also another example. I will just write here. I will also tell you why we are doing here plus equal to only 1. That means this plus plus. Okay, now we are getting correct answer, and that is because we have to take here number of equal characters and not the number of equal characters frequency. So suppose our answer is 6 and we have 1, 2, 3, 4, 5, 6. So in this case, we can just see the number of 3 characters can be present in our first array and first string, and number of 3 characters can be present in our second string, but the answer will be 1. And why 1? Because only A's are present and that are similar in our first string and second string. And the rest of the approach was same. Rest of the approach was right. I think this should work now. It's taking a lot of time today. Okay, now it is 1 here, and this will be our right answer. Not every time we can just think of a direct straightforward right approach. And return the maximum number of common characters. We don't have to find the maximum number of frequency. Okay, we just misunderstood the problem a little bit. Thanks Rohit for your suggestion. Okay, total points earned was 0. That's not a issue. So we were doing this question, right? Something like this. We don't have to get this array. We have to dynamically remove the values, right? So if we have 0 and 1, then we have to remove them entirely. And after that, suppose we have the maximum value at 3 index. So we have to remove 2 and 1. And after that, we also have to check for our 0. So every time we can just take this value at middle, or we also have to check either they should be not equal to each other. So how can we do this thing? So first of all, I'm not getting any approach. Let me just if we are adding the characters to our set, then what will happen if we are adding the values to set? 0, 1, 2 and 3, 4. 2 and 4 are present in set. Then we are at 0 index, and if it have a difference from this, then no, we cannot find that thing. So we are at 2 index, and we will just remove the characters at 1 index and 3 index. So that can be our first step, right? That can be our first step. Okay, so if we are doing this, if this is present at last, and this will be removed, this will be removed, and our number of operation is 1, and after that we can again do this thing, and this will be removed and this will be removed. Number of steps are 2, but I don't think that approach will work for all the test cases. So I think we have to do something else. Suppose in this example 1 1 1 7, and we have then 7. So we don't have to remove this 7, right? So we can just take these 3 values, and if we have some 7 here, then we can take these values. So after removing this, we have 7 here, and now we can remove these values. So total number of operation will be 3. But okay, so special operations is defined as replacing any character with any possible 26 lower character alphabets, and after doing at most k operations, return the total number of anagrams. Okay, we have to do k number of operations, and then we have to find number of anagrams at most. That means maximally k operations. So we can also do lesser than k. Okay, operations return the total number of anagrams. This can be the modulo, and we know what is an anagram. That means we can just take all the characters and manipulate them accordingly. So we have to find all the combinations of 1 2 3 4 5, these 6 characters. So in this case, k is equal to 1. That means we can first manipulate any character with all the 26 possibilities. So what is this case? After applying one operation, we can A on the first index to B and 6 possible anagrams. ABC, ACB. We have to maximize the number of anagrams, and that is obvious. If we have to maximize the number of anagrams, then that means all the characters should be distinct. So if all the characters are different, then we can just maximize the number of our anagrams, and then we have to return the number of anagrams. Okay, so if we have three number of anagrams, if we have three characters, then how can we find the number of anagrams? If we have three distinct characters, then 3 factorial, I think we have to apply here permutation. 3 factorial, that means 3 factorial will be 6, and divide by 3 minus. Okay, we don't have any r here, so that means if we have let me just try for some another test case. If our value is 3, we can replace two characters and a, so the answer will be 6 here. Answer should be 6, and that question also looks a little bit easy. Okay, we obviously have to return here some value. Done here 0. Let me just try for some different test case, different test case. Suppose we have here 4 values, and here we have b. So if we have this, then we can just change these two characters to c and d. So then 4 factorial will be 24, I think. 24. Yeah, expected answer is 24. So answer will be n factorial, the number of distinct character present, and factorial of that. Okay. So first of all, we have to find the frequency of all the characters. Think question are interesting. So this will be 26, and after that, traverse in our string. I hope you are also getting this approach, how we are going to implement this thing. So first of all, we'll get the frequency of all the characters. That means how many number of time a is present, and if a is present multiple times, then we have to obviously reduce it. So we also have to take the count of distinct character present. So how can we take it? We can create a, instead of doing this, we can create a hash map, and we can just use hash map dot size to find the number of distinct character present already. So we can just use here a map of character to integer. So map dot, we can use here this merge method. If you don't know, then using this merge method, we can just do the same thing we can do it with get or default. So for this c, we have to add one value, and we'll just use a delegate method, that is your sum. I think that is the correct method. Okay, let me just write it clearly. So what we have to write here is map dot put this c character for the value, map dot get or default this c, and 0 plus 1. So I hope now you understand this thing. So we have to put any value, put any character, and what will be the value? The previous value plus 1, and if there is no previous value, then we have to take it as 0. So we will just get the frequency of all the characters, and now we have to count the frequency of mm, what is the size, total number of distinct character. Distinct character will be now map dot size. So in this case, we have distinct character as 2. So there are two distinct character, and how many distinct character can we place is, we can just place here one. We can just add one more distinct character if we have frequency of any character more than one. So now we have to check the frequency of all the characters. So how can we check? We can just traverse in our map. So I think we can take this character, map dot key set. If c dot get map dot get of this c. So if this value is greater than 1, then that means this character have a frequency more than 1. So like in this case. So first of all, we have to check obviously that distinct should be not equal to 26, because if there are more than 20, if there are already 26 characters, then we cannot just do anything, right? So we also have to think equal to 26. Then we have to break, and at last we have to find the factorial of distinct value. And how can we find the factorial? Return factorial of this. We'll just copy this, and we also have to use this 10 to the power 9 plus 7 when we are finding this factorial. So this will return as an integer. Return a mod mod multiply factorial of a minus 1. So we are just using here, we are multiplying two values and using this modulo operator, and this is a recursive function. So the base case will be, if a equal to 1, return 1, because 1 factorial is 1, and this distinct will be definitely not equal to 0, or I think it can, no it is not. So mod value will be 10 to the power 9 plus 7. 1 2 3 4 5 6 7 8 9. So what we are doing here, a value multiply by factorial of a minus 1. So that means 3 into 2 factorial, and that will be 6 here. So if this value is greater than 1, then what we have to do? And okay, we have to check all the values, and this should be the case we are writing here inside this. If any character have a value that is greater than 1, so in this case a have 20, a is 2 times, then we have to write here while k is greater than 0 and distinct is less than 26, then distinct plus plus, and I think that's it. We have to write here this. Okay, there is no need. While let me just check here. So if we have some different at one time, and a distinct character is 26 already, so we will not enter in this block, and the maximum value of distinct will be 26. Okay, let me just check. This should work now. This should not give us any wrong answer now. Okay, so we are getting, that is because of this recursive function. So if a is equal to 1, we have to return 1. Mod value will be this, a mod answer mod multiply by I mod and mode of whole value. So this is mode property, that is why we are doing here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that means 1 into 1, then 1 into 2, so then 2 into 3, then 3 into 4. So return answer. I think this should now give us a right answer. Okay, again. What are we what are we doing wrong? Let me just know if you got this thing, what we are doing wrong here. Okay, internet is slow again. So we are creating a map, we are getting the size of map, and that means the total listing characters. So we are checking all the characters. Is there any character with more frequency? So we can alter this. So if A has more frequency, then we can just change any A to B. So A will be changed to B, and that means our distinct character count will be increased. That is not necessary that we are changing it to B. If the frequency is less than 26, then we can change it to any value. So that is why we are writing here distinct character less than 26, because there are only 26 alphabets and we are using all of them. We are assuming that. Okay, we also have to do k minus minus. At least we should submit this question. Okay, now the answer is correct. Let me, I think we should check for another test case first. For this test case, maybe for factorial 24 will be our answer. Okay, that is, now let's just submit it. I hope we will not get integer out of bound exception. This is the code, you can simply write it by yourself. There is no need to copy and paste. I am here to just explain you the solution, not to just copy paste you the code. Okay, we are getting a wrong answer again. That is your integer out of bound. If there are 9, I think 1, 2, there are 9 distinct characters, so 9 factorial will be something like this. Let me just see if 9 factorial is 9 factorial. This 9 into 8 into 7. So it is here this value. So that is the thing we are getting here. So we are getting an integer out of bound exception. We can just take here the long value and we can typecast it here. This value should be always less than 26, I think. Let me just check for this case again. Let me just copy it. 9 factorial should give us the right answer. I hope we will not again fall into integer out of bound. Okay, what is this? We are getting a wrong answer. We also have to write here while, no, not while, to get this count. C equal to C, not C, that is more characters. How many more characters are present? And we have to write here one more condition, while more characters are greater than 1. So if there are 2 more characters, we can just write it this outside of here. We can just write it here. more will be equal to map dot get of this c, and while k is greater than 0, while distinct is less than 26, while our this character is more than one time. So if it is more than one time, then we will just reduce it. So we have to reduce this character. So we have to take a value here or equal to map dot get of this c, and we can write here while this more is greater than 0, and that's it. I think that should work now. That should give us a right answer now. And I hope now all the test cases are covered. Now all the edge cases are covered, and we are completing our second answer successfully. I hope no, we are not missing any edge cases now. Okay, again we are getting a smaller answer this time. Yeah, we are getting a smaller answer this time, and there are definitely more than 26 character present out there. So we should not find the factorial of this distinct character, right? We should find the character of we should find the factorial of distinct characters plus plus there is a possibility also. Yeah, plus there is also a possibility that we are writing repeating characters, so we also have to add here the frequency of how many repeating characters are there that we have not changed. Right, all right. So we have to add some frequency here, and that will be if our k is equal to 0, then we have to, I think we have to add or we have to multiply. What was the case? Okay, we just lost the case here. Okay, no issues. So suppose we have any character from a to z, and after that we have multiple times a. So this should be not the answer will be not maximally 26 factorial, because there can be also permutations based on this thing, right? So we also have to add permutations of these values. So 26 factorial will be the permutation of all these characters. Like if we are writing ABC, then we can also write CBA, and they are unique. And if we have AAA, and we just cannot replace these values because they will not change it. We have to find the unique values, right? So suppose this example, I will just write here some example 3 and 0. Now answer will be only 1. Let me just write here more complex example. If we have here B, yeah, you can see here the answer is 1 here. You can see here, okay? You can see the answer is 2 now, and that is because of the permutations of this B. So how many places this B can be? So you can just read see there. So how many places this B can be? So B can be here, and so this is our first permutation. Okay, our answer is 2 because we have two distinct characters, but the total answer is 4 because the total positions for this B's, it can be on first index, it can be on second index, it can be third, it can be on fourth. So total possibility of this B's, first of all, we are getting 2 because of 2 factorial, 2 distinct character, and after that we have 2 more A's. So how can we use them? We can just simply multiply. I think we should simply multiply factorial of uh, extra characters. we can just get this extra. So we will just not make this int, we'll make this integer, and I will typecast here. So now we have to get this extra. So how can we get this extra? So if k is equal to 0, then that means there should be only extra characters, right? So we have to check if more is greater than 1, to add extra plus equal to more minus 1, because 1 is because 1 is obviously the distinct character value, and we are adding here more minus 1 because if there are two a's present. So if there are a present, then we have to only consider one extra a, right? I hope now you got this thing. We have, because we are not initializing this extra. Okay, I know this thing. Okay, we are getting 6 this time, and that is the correct answer. Let me check for this example. 24 into 2 will 24 into 2 will be 48. I think our answer will be 48, and expected answer is very big. So how it is even possible? We have only, okay, this is your 4. That is why we are getting a wrong answer. 1, 2, 3, 4, 5, 6. If it is 48, then I think our approach is correct. It is 20 here, and that is because two distinct characters and four extra characters, right? So I don't know. I am not getting this approach. So just let me know if you understand this thing, and I think we should now end this. So thank you for watching, everyone.